Now let us see second order passive filters. Second order passive filter means it consists of both inductor and the capacitance. In that case, it is the order of the transfer function is second order. That's why it is called second order passive filters. It consists of both resistor, inductor, and capacitor. Low pass filter. Low pass filter is it consists of a resistor, inductor, and the capacitor is shunted across this. This is input, R, L, C. This is low pass second order filter. For this, the transfer function is h of j omega equal to k omega naught square divided by s square plus omega naught divided by q multiplied by s plus omega naught square. This is the transfer function, and the resonant frequency or center frequency omega naught equal to 1 by root LC. Then the quality factor equal to Q equal to 1 by R root L by C. Quality factor equal. So these are the parameters. If omega naught is given, we can find L and C for this type of filter. For high pass filter, resistor and capacitor are in series. And the inductor is shunted across this. Then it is called high pass filter. High pass filter. Here also the H of S equal to K S square upon S square plus omega naught divided by Q multiplied by S plus omega naught square. Here also omega naught equal to 1 by root LC, and the quality factor Q equal to 1 by R root L by C. The same. Then band pass filter. Band pass filter means for high pass filter the response will be like this. For low pass filter it will be like this. Omega modulus of h of j omega. Modulus of this is modulus of h of j omega x-axis. Band pass filter means here it passes only a band of frequencies. In that case, capacitor and the inductor are in series. The output is taken across a resistor. This is called band pass filter. Band pass filter. Its transfer function h of s equal to ks multiplied by omega naught by ks multiplied by omega naught divided by q whole divided by s square plus omega naught divided by q multiplied by s plus omega naught square. And here also the center frequency omega naught equal to 1 by root LC and q equal to 1 by R root L by C. Band pass filter. Band pass. So this is band pass. The band of frequency between omega 1 and omega 2 will be passed. This is called the band pass filter. Next one is band reject filter. Band reject filter. The band reject filter the resistor alone is in series and the capacitor and the inductor are in shunted. This is called band reject filter. In that case, HF is equal to S square plus omega naught square. S square plus omega naught square divided by the same S square plus omega naught divided by Q multiplied by S plus omega naught square. Here also the center frequency is this is omega naught. Center frequency omega naught equal to 1 by root LC and Q equal to 1 by R root L by C. The same for all systems, and K equal to gain of the filter is 1, K equal to static gain, DC gain equal to 1. Here also DC gain equal to 1. That's all. By using this formula, we can design a controller. Suppose we have to design a band reject filter. Band reject filter means it will reject this part will be rejected. So it allows up to this omega 1. Up to this it is blocked omega. Between omega 1 and omega 2, it is blocked. By using this formula, we can you can solve the sums. For example, this is omega naught. Here, this is omega naught. So by using that, you can find the relation between for low pass and high pass filter. The relation between omega naught equal to square root of omega 1 and omega 2, where omega 1 and omega 2 are lower and upper conductor frequencies. The difference between the two is called bandwidth. So this is for low pass and high pass filters. Low pass, high pass, either omega 1 or omega 2 will be for low pass filter omega 1 equal to 0. For high pass filter omega 2 equal to infinity. For all other filters, you can take omega 1 and omega 2.